Assalamu alaikum everyone. We are starting with the revision of normal distribution from the past papers. So what you see over here are the 2023 past papers. So let me just scroll down and look for a question that is related with normal distribution, and it could be a combination with binomial also. So now let's look at this question. So now the question says, a mathematical puzzle is given to a large number of students. The times taken to complete the puzzle are normally distributed with mean 14.6 and standard deviation 5.2. Part A, in a random sample of 250 students, how many would you expect to have taken more than 20 minutes to complete the puzzle? So now, first of all, let me add a page over here. And I think I'll just add a page over here. Let me form a notebook. And that's all black. And the paper is squared. And this is S1. And this is normal review. So let me just change the color of the page for a second. So dark is good. Unruled white. Okay. So now over here, what I'm focusing on is this, that if we talk about normal distribution, we know that X follows a normal distribution mu comma sigma square. What is mu? That is the mean. What is sigma square? That is the variance. Square root of variance is standard deviation. So sigma is SD, standard deviation. How do we standardize? We standardize Z equals to X minus mu over sigma. So now from the given value, we subtract the mean. There is a minus sign, and then we divide by standard deviation. We get the Z value. And then there are 7 rules. And these 7 rules are used to use the Z value to find probability. So let me recap those 7 rules for you. Rule number 1, that is probability Z is less than A. That's also written as phi of A. This is reading the value directly from the table. And let me draw a diagram over here so that we can understand it. So now this diagram is over here, and we are talking about a positive value. So let me first draw a vertical line over here, something like this. And then there is a particular Z value like this. And then let me do some shading. So we are looking at this region, which is right over here. So we go to the left of this region. So this is the value that we read directly. So this is direct reading. If this value is A, this is phi of A, and this gives the area under graph. So this is the first rule. The most basic rule is the first rule. Normal distribution is based upon the concept of less than. This is 0 over here. Positive values are on the right, negative values are on the left. And the table that we use, the table is only for positive values of Z. So that is the first basic rule. Now let me move to the second rule. That is rule number 2. That rule says that probability Z is greater than or equal to. By the way, it's a continuous distribution. So since normal distribution is continuous, greater and greater than equal to is the same thing, lesser than or equal to is the same thing. This is 1 minus probability Z is less than or equal to A, which is 1 minus phi of A. So now again, if I use this graph over here, and let me draw a vertical line in the middle like this. So that's a vertical line right over here. Let me just shift this vertical line a little bit like this. And let me draw the same A over here, and this is A. And now we are interested in this area under graph. So this is 1 minus phi of A. So basically we read the table for this and then we subtract it from 1. So these are the two basic rules. So now rule number 2 is done. Let's look at rule number 3. So rule number 3 says this, that probability Z is greater than or negative value. So let's say over here, let me first draw a vertical line over here, another vertical line like this, and then let me draw negative A over here. Let me draw positive A over here. And let me shade the region. So this region is shaded. Over here, this region is shaded. Probability Z greater than negative A. So this is negative A. This is probability Z greater than or equal to negative A according to symmetry. This is the same thing as probability Z is less than or equal to positive A. So according to symmetry, that's the same thing as probability Z less than or equal to positive A. What is the thing that we have done? We have flipped the inequality. So flip inequality and remove negative sign. So when we do this, isn't this thing the same thing as rule number 1? Yes. So rule number 3 actually becomes rule number 1. And what is rule number 1? That is reading directly from the table. Now, similarly, let's look at rule number 4. So if I write over here, rule number 4, again, let me draw a vertical line first. Not like this, a vertical line like this, a vertical line like this, and let me mark a value over here, and let me just shade the region. Okay, so this is negative A, this is positive A, this is something. According to symmetry, you can see that this is exactly the same. So rule number 4 says probability Z is less than or equal to negative A. This is probability Z is less than or equal to negative A. What is it equal to? Probability Z is greater than or equal to positive A. This is probability Z is greater than or equal to positive A. Again, what is the rule that we applied? That is flip inequality and remove negative sign. Why are we removing the negative sign? Because the normal distribution table is not for negative values. So now this thing, isn't this thing rule number 2? So rule number 4 is basically the same thing as rule number 2. Z is greater than or equal to A. Z is greater than or equal to A. What does it become? 1 minus probability Z less than or equal to A, 1 minus phi of A. So this is 1 minus phi of A. So probability Z less than or equal to negative A, probability Z greater than or equal to positive A, which is 1 minus phi of A. Read the value. The probability that will be given in the table will be this. Subtract from 1, you will get this answer. Now the next 3 rules are right over here. Again, I'll be using a divider over here. So let me first divide it properly. And let me just draw a vertical line going all the way like this. Okay, that is good enough. Let me just change the diagram. Okay, all good, all clear. The next thing, let me use an eraser over here. Okay. And then let me mark some values. Let me make it bigger. This is 0. And let me mark two values over here. Let's say one value is like this and the other value is like this. Similarly, one value is like this, the other value is like this. Similarly, one value is on this side and other value is on this side. Now, what do you observe? Over here, first of all, 0 is there. That is the middle value. These two z values are positive. So this is positive A, positive B, and we are looking for the area between these two. Over here, this is negative C, negative D. We are looking for the area between these two. This is G, this is H. We are looking for the area between these two. Let me use another color. Okay. So this is AB. Over here. So this is negative C, negative D. Okay. So now there are three more rules over here. This is rule number 5. Rule number 5, it says that probability Z lies between two values A and B. Both values are positive. Naturally, B is bigger. Read the table for the big, read the table for the small, and subtract. We are not going into the logic behind it. Rule number 6, we went over the logic in class. So that is why we are not going it over here. Now, these two values are there. They are negative. This is more negative. This is smaller value. So probability Z lying between two values, negative C, negative D. First of all, we remove the negative sign. So now which one is bigger? So C will be bigger, D will be smaller, and therefore probability, read the table for each, that is C minus D. Because this is the mirror image of what? So if there is over here negative C, this negative C will go on this side and this will become positive C. This goes on the other side and becomes positive D. So C is bigger, D is smaller. Probability of C, phi of C minus phi of D. And the last rule, that is rule number 7, that is if it lies between two values, one is negative, the other one is positive. So this is phi of the first value plus phi of the second value minus 1. The logic is a bit deeper. So just apply this and you will get it correct. Similarly, when we apply the concept of back solving. So what is back solving? That is using the probability value to find the z value. There are only two rules. The golden rules are rule number 1. That is, make sure probability is at least 50%, 0.5 or above. That is the first thing. Rule number 2, that is, if its probability z lesser than something, then this means z value is positive. And then the other rule is probability z is greater than something, then over here it means that the z value is negative. One other thing that I need to add is this. If this is not the case, if not, subtract probability from 1 because the total probability is 1 and flip the inequality. And all these working we will soon see in our past paper review. Once this rule is fulfilled, then apply rule number 2. Now if z has a lesser sign, z value is positive, z has a greater sign, z value is negative. So I'm coming back over here and the first question is over there, which you can see. It says a math puzzle is given to a large number of students. The times taken to complete is normally distributed with mean this much and standard deviation this much. In a random sample of 250 of the students, how many would you expect? So now this expect is about expectation, that is NP. That means whenever we are talking about more than one student, binomial comes into play. So we will say X follows a binomial distribution N comma P. This P will be obtained from normal distribution. N is right over here. Now look at the working. X follows a normal distribution. Just write down the data, describe the distribution. Find probability. Probability X is less than 20, greater than 20. 20 minus 14.6 divided by 5.2. We convert it into Z. Work in 4SF. And then we go to the Z table, and that is for 3dp. So 4SF in this case is 3dp. Directly reading from the table, because why? This is rule number 2. This is direct reading, and then this is rule number 2. Probability Z greater than a positive value, 1 minus 5 of that value. This value from the table is this much. This is 4dp value. Subtract from 1 and then round it off if this was the final answer. Since this is not the final answer, you don't have to round it off. You have to work it out, and then if there is a need, depending upon the scenario, you have to round off. Step 2. Y follows a binomial distribution. This is N, this is 0.1496. Expectation of Y is 37.4. We are talking about students, so we cannot give the answer in decimals. The examiner will be really furious if you give the answer in decimals. You have to round it up or round it down, both are acceptable. So if I round it down, this is 37. If I round it up, this is 38. Both are correct. This is basically ratio out of 1. This is the fraction or decimal that belongs to that category. Out of 250, how many? So I have done it using direct proportionality also. Now it says all the students are given a second puzzle to complete. The times and minutes are normally distributed with mean mu and standard deviation sigma. It is found that 20% of the students have time less than 14.5, 67% have times greater than 18.5. Find the value of mu and sigma. So this time, this thing is gone. It's not given. That is mu and sigma. So what do? We apply the rules of back solving. We form two equations with two unknowns and we solve it simultaneously. So a bit of arithmetic, a bit of simultaneous equation and algebra. And of course, it's about normal distribution. So X follows a normal distribution this much. Back solving using probability to find the Z value. 20%, this is less than 50%. Subtract from 1, that is 80%. 1 means 100%. So you can work in either in decimals or in percentage. When you are working in percentage, subtract from 100. When you are working in decimals, subtract from 1. So for 80%, the corresponding Z value is 0.842. This is from the big table, and then you look for that particular value, read the first decimal place, the second decimal place, the third decimal place. So you know that rule. 67%, the corresponding Z value is 0.44. So work this out first rather than starting the working and then going back and forth. I mean, that will waste your time. So now the first thing, the blue thing, 20% have time less than 14.5. Probability X is less than 14.5 is 20%. Since this is lesser than 50%, subtract this from 1 and flip the inequality. So this is flip and this is subtraction. Then we will standardize with two unknowns. The 80% Z value is this much, but since this is greater, we give it a negative sign. So that's the first equation right over here. I hope it's all good, all clear, understood by everyone. Probability X is greater than 18.5, that's 0.67. Probability Z is greater than 18.5 minus mu over sigma. Standardize. And now this is greater, so it gives us a negative value. We just went over this rule, that's right over here. Z is lesser than something, Z is positive, Z is greater than something, Z is negative. But before that, make sure the probability is at least 0.5. If not, subtract probability from 1 and flip the inequality. I can even write this thing that subtract probability from 100%, subtract percentage from 100% and flip the inequality. So that can also be written. Coming back to this, apply the same rule over here. We get another equation. Sigma is all alone. Mu is with a number. So just make sigma the subject, just make sigma the subject. Then this equals to this, cross multiply, simplify, and then you get two answers rounded off to 3 SF unless otherwise stated. So now let me focus on the accuracy also, and then we'll go to the examiner report. What is the accuracy that they are talking about? Answer all questions, use this kind of pen, use this kind of pencil, and name and center number in candidate. Write your answer to each question in the space provided. Do not use an erasable pen of correction fluid. Do not write on any barcode. No, don't do it. If additional space is needed, you should use the lined paper at the end of this booklet. The question number or numbers must be clearly shown. You should use a calculator where appropriate. You must show all necessary working clearly. No marks will be given for unsupported answer from a calculator. That means if you do not show the working, you just plug in these two equations in the calculator, write down the answer, you won't be obtaining any mark. Give non-exact numerical answers correct to 3 significant figures. That is the general rule. Or for angles in degrees, unless, or 1 decimal place for angles in degrees, this is P1, unless a different level of accuracy is specified in the question. So now, first of all, let me just show you what is the space that is given over here. For a second. So now this is the page, and I think they have removed the extra pages from here. Otherwise, the extra page should have been over here. So I think 2 kind of pages will be given over here. Now this thing is done. Now let me take you to the examiner report. Okay, that's right over here. Now it says candidates need to be aware that working and explanations are required to support the answer. It is especially important to include all the required steps when proof of a given result is called for, including the mathematical operations, plus, minus, multiply, divide, square root, square, cube root, cube, factorization, and so on. Good solutions were characterized by clear communication, particularly when combining different results or scenarios. Okay, when a diagram is required, it should be clear, accurate, and appropriately labeled. So now, these things that you are seeing on my YouTube channel, Mathematics with Shahab Yaqub, keep in mind this is a revision. So I mean, I do upload some past papers over here, I do upload some lectures over here, but of course there are live classes in which you learn everything step by step. And at the end of that, or the classes at my college where I teach, so when you go through every single step over here, then you develop that confidence of doing things very, very properly. Right now, it's just a review. So now if I go over here, we are talking about normal distribution. I think this is the one. So let me just erase this thing. And let me first explain you this thing and I'll write it down. So now it says the vast majority of candidates. So let me just choose this color. The vast majority of candidates were able to use the normal standardization formula correctly. Most candidates correctly identified that as time is a continuous variable, no continuity correction was necessary. I mean, this could be also like this, that we use continuity correction when we use normal approximation to binomial. When it is clearly specified, when it is a need of the hour, that is when we use it. The best solutions were often accompanied by a simple diagram to inform the method. But if you are very, very accurate about the rules, then diagram is not even necessary. In few instances, a continuity correction was applied or variance was used. That means there was no need. So people still use continuity correction or variance. So this is basically what is it referring to, that these are the mistakes that were made. Candidates must obtain an accurate probability, must appreciate the need to use the full value obtained from the normal distribution table to obtain an accurate probability. Some stop after finding the probability. Candidates would be well advised to ensure that they read through the question carefully, because it was not asking for probability, it was asking for expectation. They fulfill its requirement, all of its requirement. Some better responses showed calculations of the number of students by multiplying by 250 and appreciated the need to give the answer as an integer without extra solutions on any reference to rounding off, because since we are talking about number of students, so you have to round it off. And then later on, what does it say? The finding of mu and sigma for the given information is a familiar application of the normal distribution. Strong candidates often provided a supporting diagram. I mean, I don't like diagrams in this particular scenario because the rules the way that I've explained it, I mean, they are self-sufficient. Diagram is not necessary at all. Identifying the probabilities given in the question, they went on to give the correct z values corresponding to those probabilities in two standardization formulas. Information in the diagram allowed them to see that both z values should be negative. We already worked on that. That is how we worked on that. That is the golden rule that I have taught. So this is without a diagram. This is definitely based on the diagram initially, but then we generalized it. So be confident in how you work it out. Most candidates who obtained the formula were able to solve their system of equations to provide answers for both mu and sigma. This is simultaneous. Some candidates prematurely rounded their z values, leading to inaccurate solution. Very important. Do not do premature approximation. Weaker solutions use the given probabilities as z values. So this is again a mistake that they are talking about. So do not do this. So that is the kind of working that needs to be done. And I've explained this particular question very thoroughly. So now let me move on and find a question for you to try. So I'll just pause the recording once I have found the question. And I think there it is. So let me just pause the recording. That's right over here. So now let's look at question number 5. It says, the length of western bluebirds are normally distributed with this mean and this standard deviation. A random sample of 150 of these birds is selected. How many of these birds would you expect, just like the question we discussed, have length between 15.4 and 16.8? State the distribution. This is how we do the standardization. W for western bluebirds lie between 15.4 and 16.8. Standardize, these are the values. One z value is negative, one z value is positive. This is rule number 7 according to our numbering. Read the table for this value, that's the probability. Read the table for this value and then subtract 1. This is the answer. Now we are looking, okay, I've written rule number 7 over here. Now over here, x follows a binomial distribution n comma p. Expectation of x is np. This is the probability, that's the value of n. We get the answer, that is 98 point something. Our choice, round it down, round it up. Again, we are talking about birds. It has to be an integer. The second part, it says the lengths of eastern bluebirds. Those were western, these are eastern. They are also normally distributed. This is the mean. Standard deviation is unknown, one unknown. We did a question with 2 unknowns. This is 1 unknown. It is known that 72% have length greater than 17.1. Probability x greater than 17.1 is 0.72. This is more than 15% greater. That means the z value will be negative. Go to the main table, read for 0.72. This is the corresponding z value. Compare coefficients, simplify, you get the value of sigma. The third part, that is normal approximation to binomial. A random sample of 120 eastern bluebirds is chosen. Use an approximation to find the probability fewer than 80 of these 120 bluebirds have length greater than 17.1. So there is this value. Keep your eyes wide open. Keep your ears on. So now you have to be vigilant. You don't have to start working again. Just think that it is related to the previous part. What is the probability that the percentage is greater than 17.1? That is 72%. So 72% is your success. 120 is your number of trial. Write it out separately. Calculate NP, calculate NPQ, calculate NQ. Whether they ask us to justify or not, go ahead and justify. NP should be greater than 5, NQ should be greater than 5. NP is greater than 5, NQ is greater than 5, and then this NP is the mean that goes over here. This NPQ is the variance that goes over here. Do not mix these two. This is for justification. This is for justification as well as mean. So now lesser than 80 continuity correction, the lower class boundary LCB is 79.5, upper class boundary is 80.5. This is not inclusive. You cannot use this value because this is from discrete probability distribution. Normal is a continuous probability distribution. You are going in the leftward direction. The green number line is including this. The blue number line is excluding this. Since 80 is excluded, therefore choose 79.5. Standardize, you get the Z value, apply the relevant rule, and then you get the answer correct to 3SF. So there were 3 things over here. What were those 3 things? From the first 7 rules, one of the rule is applied, and then binomial is used to calculate expectation. Over here, we are doing back solving, using the probability to find the Z value and then finding one of the unknowns. And this one is normal approximation to binomial. The probability was used from the previous part. Justification was done. Continuity correction was done. Then again, one of the 7 rules that is applied over here. So now let me move on to some other paper. And I think it's a good idea to just go through what people went through in this question. Okay, so let me grab the straight line thing. Question number 5. This was relatively standard normal approximation question. The number of candidates who did not attempt part C was higher than anticipated. That means people are so weak in the basics. I mean, it's not a nice thing to say, but not everyone is lucky enough to be taught properly, to receive the proper education. So feel grateful that you people are fortunate enough to get a good understanding of it, getting a good grasp of it, and then applying the knowledge. Now over here it says almost all candidates use normal distribution standardization formula correctly at least once. The best solution often had a sketch. We talked about the sketch. Very few candidates used a continuity correction. There was no use of it, which was not required. So I don't know why people are using continuity correction too much. A common misinterpretation was that the required probability area was symmetrical and all the correct standardization formula was stated. The second evaluation was assumed and not calculated. I don't know, people make all these kind of mistakes. And then many solutions finish when the probability area had been calculated with the final process required to find the expected number of birds that fulfilled the criteria not attempted. People did not read the whole question. Candidates are well advised to read the question again once they reach the final answer to check that it is both reasonable, a very good advice, and does answer the question. Because of the context, the final answer needed to have an integer value, and there should be no indication of rounding as the value chosen is a decision from the candidate. You can round it up, you can round it down because it has to be an integer. Candidates should also be aware that the evidence of probability to at least 4 significant figures is required to justify the decision. The next one, a fairly standard normal approximation technique was used. Good solutions were used for normal distribution to identify the magnitude of the anticipated Z value. We have our golden rule. Candidates formed an appropriate equation using the normal standardization formula were frequently successful in determining the value of sigma. Many candidates found a probability value rather than a Z value. This is a mistake from the information, so were unable to form an appropriate equation. Candidates should be aware that the supporting work needs to be consistent throughout the solution. A number of candidates realized that the standard deviation could not be negative, so stated a positive value. That is again a mistake. I mean, it was not coming out to be negative. They just had to be aware that the Z value was negative. That negative cancelled out, but did not amend the initial error of the incorrect Z value. So a lot of lessons need to be learned in life. Okay, now this one. It says Again, even though this question was not attempted by many candidates, very strange. Several good attempts at the standard normal approximation question was seen. The best solutions had calculations of the mean and variance initially, then a substitution of these values in the normal approximation formula. Many candidates recognized that the data was discrete, so required continuity correction, although few used the upper rather than the lower bound. That means they realized that continuity correction was needed, but they made a small error in choosing the wrong boundary. Instead of the lower class boundary, they chose the upper class boundary. That is why I emphasize to draw a small diagram, show every single piece of work. The most common error was to use the incorrect probability area, which may have been avoided if a simple sketch of the normal curve was used to clarify the success criteria. So that is the working for this particular part. Let me just pause the recording, hold for a second. So I'll just pause the recording and share another question with you. So now let's look at this last question. It says, the mass of grapes sold per day by a large shop can be modeled by a normal distribution. This is the mean. On 10% of the days, less than 16 kg of grapes are sold. Mean is given. Variance or ST is unknown. Probability x less than 16 is 10%. We are doing back solving. Subtract probability from 1. 10% is 0.1. When we subtract, this becomes 0.9. From percentage, 100 minus 10 is 90%. 90% is 0.9. It's your approach. Inequality is flipped. Greater sign, Z value will be negative. 90%, you look at that strip, that's at the bottom of the normal distribution table. The 9 values are given over there. The value corresponding to 90% is 1.282, negative sign from before. 16 minus 28, that is a negative 12 over sigma is negative 1.282. Now let's say if someone forgot about the negative sign. This is negative 12, this is sigma. Sigma has to be positive. Standard deviation is a positive value. That means there was a negative sign over there which someone overlooked. Any which way, you find the value of sigma, which comes out to be this. The next part, the mass of grapes sold on any day is independent of the mass sold on any other day. Now, why have they mentioned independent? Because when we talk about binomial and we talk about that the number of trials, which is the mass of grapes, that is independent number of trials. How many days we are talking about, that is independent of one another. The number of trials is fixed, the probabilities are fixed, and so on. So that is why they have written this. 12 days are chosen at random. Find the probability less than 16 kg of grapes were sold on more than 2 of these 12 days. So now over here again, less than 16 kg of grapes, this is the success. That is the success that goes over here. This is the number of trials. More than 2 is greater than 2, greater than or equal to 3, which is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's too many, which is 1 minus probability of 0, 1 and 2. So this is the calculation for 0, this is the calculation for 1, this is the calculation for 2, according to the binomial formula. X follows a binomial distribution n comma p. Probability x is equals to r, that is NCR, success raised to power of r, failure raised to power of n minus r. That is what is used over here, and this is the final answer. Just write all this thing in the calculator. Even if you want to put a big bracket and write a 1 before, you will get the answer. Make sure to write the 4 SF value and then the 3 SF value. And then the last part. It says in a random sample of 365 days, how many days would you expect? Expectation, this we are seeing it for the third time in this particular class. The mass of grapes sold will be within 1.3 standard deviation of the mean. This is mu. This is mu plus 1.3 sigma. This is mu minus 1.3 sigma. Within 1.3 standard deviation of the mean, the deviation can be on either side. So when we simplify, you don't even need to plug in the value of mu and sigma because it will all cancel out. The mu's cancels out, leaving behind a 0. The sigmas cancel out in division, leaving behind a 1. So this is probability x lies between these two values. Actually, let me just do the correction. this x becomes z. So let me write over here, this is z. So then let's proceed. Z lies between these two values. One is positive, one is negative. Read the table for the first value, read the table for the second value. Naturally, you have to dump the negative sign, discard the negative sign. Rule number 7, and this is the answer. But wait a minute, read the question again. They are not asking for probability, they are asking for expected value, expectation. So NP 365 into this value, either 294, either 295. This is the answer. It's not a matter of rounding off. It's a matter of writing the answer as an integer. Why? Because we are talking about the number of days. So that completes this lecture on normal distribution. See you in the next class and good luck with your exams.